We now discuss the solution of a problem from the section Differential Calculus, and the problem is on the continuity and differentiability of a given function. This question has appeared joint entrance examination main held on 27th July 2021 in the second shift. The problem is, let f be a function from defined on the semi-closed interval 0 to infinity, closed at 0 end, to the closed and bounded interval 0 to 3 be a function defined by f of x is equal to maximum of sin t, where 0 less than or equal to t less than or equal to x and 0 less than or equal to x less than or equal to pi. 2 plus cos x when x greater than pi. Then which of the following is true? We are given four options. Option 1, f is not continuous exactly at 2 points in the open interval 0 to infinity. Option 2, f is continuous everywhere but not differentiable exactly at 1 point in the open interval 0 to infinity. Option 3, f is differentiable everywhere in the open interval 0 to infinity. Option 4, f is continuous everywhere but not differentiable exactly at 2 points in the open interval 0 to infinity. So that is, we have to discuss the continuity and differentiability in the open interval 0 to infinity of this function. This function is f of x is equal to the maximum of sin t, where 0 less than or t less than or equal to x and x varies from 0 to pi including 0 and pi, and 2 plus cos x when x greater than pi. We now discuss the solution of the problem in detail. So we are given a function defined from the semi-closed interval 0 to infinity, closed at 0 end, to the open and closed and bounded interval 0 to 3, defined by f of x is equal to like this. Now let us see the first part, maximum of sin t, where t varies from 0 to x when x varies from 0 to pi. So maximum of sin t, 0 less than or equal to t less than or equal to x and 0 less than or equal to x less than or equal to pi by 2, that will be sin t, and t varies 0 to x varies 0 to pi. 0 to pi by 2 we have taken. So that means it will be sin x only. Why? Because sin x is a strictly increasing function in the interval, closed and bounded interval 0 to pi by 2. So it takes the maximum value sin x only in this interval. Now, once this x crosses pi by 2, the maximum value of sin t will be 1. From sin t will be 1. So maximum of sin t, 0 less than or equal to t less than or equal to x, will be 1 when x crosses pi by 2 and goes up to pi, that is pi by 2 less than or equal to x less than or equal to pi. So thus our function f of x now becomes sin x in the closed and bounded interval 0 to pi by 2, and it is 1 when pi by 2 less than x less than or equal to pi, and beyond pi, x greater than pi, that will be 2 plus cos x. So we now take that function and discuss about its continuity first. Now, this function is continuous everywhere except possibly at x is equal to pi by 2 and at x is equal to pi. So, we will see whether there are any breaks at this point, pi by 2 and pi. Note that fx is continuous everywhere in the interval 0 to infinity except possibly at x is equal to pi by 2 and x is equal to pi. Now, let us see, limit extends to pi by 2, minus means from the left, x is tending to pi by 2 from left here, that is of fx, limit extends to pi by 2 of sin x, because x is tending from left, that means in this interval it is sin x. So, limit extends to pi by 2 sin x, that is 1 sin pi by 2. And the limit extends to pi by 2 plus, that is extending to pi by 2 from right in this interval, that is 1. So, limit extends to pi by 2 of 1 is 1. So, they are equal. Both the left hand limit and right hand limit at x is equal to pi by 2 exists and they are equal. Therefore, fx is continuous at x is equal to pi by 2 and f of pi by 2 is the common value, that is 1. F of pi by 2 is 1. So, similarly, we can also show that fx is continuous at x is equal to pi and the value of f at pi is 1. We continue in the next slide and talk about its differentiability. So the continuous everywhere except possibly at x is equal to pi by 2, x is equal to pi. At these 2 points also it is continuous. Therefore, it is continuous everywhere in the interval 0 to infinity. So, we discuss its differentiability in the next slide. That's our function. Now, this is fx is differentiable everywhere 0 to infinity except possibly at this x is equal to pi by 2 and x is equal to pi. Let's see at x is equal to pi by 2. So, f prime pi by 2 minus, that is the left hand derivative. The left hand derivative will be, left hand derivative means in this limit h tends to 0 f of pi by 2 minus h minus f of pi by 2 by minus h, and that is limit h tends to 0 f of pi by 2 minus h means in this interval sine of pi by 2 minus h, f of pi by 2 value which we have seen in the last slide, that is 1. So, minus 1 by minus h, and this is cos h minus 1 by minus h, limit h tends to 0. So, this takes a 0 by 0 form, use the L'Hopital's rule, and the derivative of cos h minus 1 is minus sin h by the derivative of the denominator, that is minus h is minus 1. Now, take the limit h tends to 0 of sin h, that is 0. We talk about the right hand derivative. So, f prime pi by 2 plus, so limit h tends to 0 f of pi by 2 plus h in this, pi by 2 plus h minus f of pi by 2 by h, and f of pi by 2 plus h, that means in this interval the value is 1 and f of pi by 2 value is 1, which we have seen in the last slide, by h, and limit h tends to 0 of 0 by h is 0. Agreed. That means both the right hand derivative and left hand derivative exists at the point x is equal to pi by 2 and the common value is 0. Therefore, its derivative is 0. So, f prime at pi by 2 is 0. So, thus fx is differentiable at x is equal to pi by 2. In a similar manner, you can also see fx is differentiable at x is equal to pi, and the derivative at x is equal to pi is again 0. Right. So, that means fx is differentiable at these 2 points, and fx is differentiable everywhere in this interval. Therefore, fx is differentiable everywhere in the 0 to infinity. Let's look at our options, and our conclusion that fx is differentiable everywhere in 0 to infinity appears against the option 3, that f is differentiable everywhere in 0 to infinity. And in the remaining options, that is option 1, 2 and 4, so there are some exceptions. So our answer is option 2. So that is the discussion of the solution of the problem. But I will show you the graph of this function. Let's see the graph of this function. So the graph is ready, agreed. So 0 to pi by 2, it is the sin x. It is the sin x. From pi by 2 to pi, it's 1. It's 1 up to pi. After pi, 2 plus cos x. That means cos x is shifted upwards by 2 units after x is equal to pi. So that's the one. And the continuity is maintained, and the curve is smooth at x is equal to pi by 2 and x is equal to pi. We do not have any corners. So therefore, it is differentiable everywhere. So fx is continuous everywhere, and fx is differentiable everywhere. So that's the discussion of the solution of this problem. I am sure that you have understood the solution of this problem, and go on working out similar problems from a standard textbook. I wish you all the best. Thank you.